All right, let's just jump right in. If you're an engineer or an SRE who's touched generative AI, you've probably got this nagging feeling. This sense that the old rules just don't apply anymore. All of our tried and true playbooks for monitoring and observability, yeah, they're starting to fall apart. Today we're going to figure out exactly why, and more importantly, what we can do about it.
So, let's start with ground zero for any on-call engineer, right? The question, is the service up? You glance at your dashboard, you see a 200 OK, requests are flowing, everything's green. You think you're safe. But here's the thing. With GenAI, that question isn't just basic, it's a trap.
It is absolutely the wrong question to be asking. Because the GenAI service can be up, it can be accepting requests, looking perfectly healthy, and at the same time be failing in the most catastrophic ways. We're talking burning cache, infuriating your users, and performing horribly, all while your traditional dashboards are giving you the green light.
To really get why, we have to talk about a fundamental shift. It's not just about new tech. The actual work our systems are doing has completely changed. We've gone from a predictable world of neat, tidy requests to this wild universe of unpredictable variable token streams. And that, my friends, changes everything. Just look at this breakdown. On the left, that's our comfort zone, right? A request is a known quantity. Latency is mostly about CPU and I/O. Cost is some pretty simple math. But now look at the right. In the GenAI world, one request could be a tiny bit of work, the next could be a monster. Latency isn't just about CPU anymore, it's hiding in these weird, complex places like batching and GPU scheduling. And cost? Forget requests per second. Cost is all about tokens.
And that brings us to the new rule of the game. We have to evolve. We have to start practicing what's called token-aware observability. This means we literally have to retrain our brains to stop thinking in requests per second and start seeing the world in tokens per second. This isn't just some new metric you add to a dashboard. It is a completely different way of seeing the health of your system.
Okay, enough theory. To make this really hit home, let's walk through a real-life war story. This is a production incident that perfectly shows how dangerous it is to be blind to tokens. A silent failure that would have stumped any SRE who is still using the old playbook. So the story begins with something great. The service is a hit, it's popular, and user traffic suddenly doubles. For most services, you pop the champagne, right? Well, in this case, it was the start of a very, very bad day.
So the on-call engineer gets an alert, looks at the main dashboard, and sees this mess. And it makes no sense. P99 latency has just exploded. We're talking from a snappy 600 milliseconds to an agonizing 4 seconds. The queue of requests waiting to be processed is shooting to the moon. But, and this is the crazy part, the GPUs, the most expensive, powerful part of the whole stack, are just chilling out at 35% utilization. What is going on?
So what's your next move? The GPUs look totally fine. They're practically yawning. So your brain immediately jumps to, okay, the model itself must be slow, or we need to throw more servers at this problem. But here's the kicker. Based on those old metrics, you'd be 100% wrong, and you'd probably just make things worse. The real culprit is hiding in plain sight, if you know where to look.
And here it is. It was never about the GPU being slow. The bottleneck was in front of the GPU. It was a simple configuration line. The max batch size was stuck at a low number, just 8. So as all this new traffic flooded in, requests were just sitting there, piling up in a queue, waiting for their little group of 8 to be ready. The GPUs were literally being starved of work. They were ready to go, but the system couldn't feed them fast enough.
So once the team finally understood the real problem, the fix was almost laughably simple. They just increased the max batch size to let more requests get processed at once, and they flipped on a feature called continuous batching. That's it. No new hardware, no code changes, just a couple of config tweaks.
And the results? Whoa, just look at this. Latency immediately dropped right back down to normal. GPU utilization shot up to a super healthy 82%, meaning those expensive chips were finally pulling their weight. And because they were now doing way more work with the same hardware, the cost per request plummeted by 28%. That is the power of being token aware.
Okay, so that story was the why. Now let's get into the how. What are the actual tools and the specific metrics you need to build a system that can see these silent failures before they bite you? Let's open up the expert's toolkit. So at a high level, your monitoring has to cover these 4 pillars. These are non-negotiable. You need deep GPU metrics, way beyond just basic utilization. You need to track your actual inference performance in tokens per second. You need clear capacity signals like queue depth, And you absolutely have to connect all of it back to cost.
And you know what the best part is? You can build an absolutely world-class observability stack using incredible open-source tools. For those deep GPU metrics, NVIDIA's DCGM is the gold standard. For your app and, most importantly, your token metrics, something like the vLLM inference server exporting to Prometheus is perfect. You pull it all together in Grafana dashboards, and then you get your secret weapon, distributed tracing with OpenTelemetry.
I really want to hammer this point home. DCGM, that's Data Center GPU Manager, is not optional. It's what gives you the low-level stuff, like SM occupancy, that actually tells you if the GPU's cores are busy doing math or if they're just sitting around waiting for data. Without DCGM, you are flying completely blind to the exact GPU starvation problem we saw in that incident. And that other secret weapon, tracing. Look, metrics tell you what's happening, but traces tell you why. A trace will follow a single request through its entire journey and show you exactly where every millisecond was spent. How long in the queue, how long waiting for a batch to fill up, how long in actual GPU compute. This is how you find and destroy P99 latency.
But having all the right tools is only half the equation. The other half, and I'd argue the more important half, is about changing how you think. It's about developing the mindset of an expert who really understands these massive, complex AI systems.
So if you walk away with only one thing today, let it be this. I mean it. If you are not graphing tokens, you simply do not understand your system. End of story. Tokens per second, cost per token, latency per token, that is the new heartbeat of your GenAI service. Everything else is just noise.
And this all leads to a really critical shift in how we define success. See, observability isn't about having a wall full of pretty dashboards. That's just passive monitoring. True observability is about action. It's a measure of speed. How fast can your team get from, uh-oh, there's an alert, to, aha, that's the root cause? That's the only thing that matters.
Which brings us to the final, ultimate question. This is the question an expert asks. This is the question your entire system, your dashboards, your alerts, your mindset, everything must be built to answer. Is our AI slow because of the model itself, a weird user prompt, the GPU hardware, or is it our own queuing and batching logic? If you can't get a confident answer to that in under 5 minutes during a fire, you don't have true observability. But now, you've got the map to get there.